Hello everybody. Let's just talk about the BCD addition. Okay, so for this you have to understand what is BCD first. So BCD, as from the name, it suggests the binary coded decimal. Okay, so very first thing to note here is you have the decimal thing here. Okay, so what are the decimal numbers? Okay, so decimal numbers are numbers from 0 to 9. Okay, what I mean by this is if I write 0 1 2 3 4 5 6 7 8 9. Okay, so these are decimal numbers, and the total will be 10 numbers. Okay, starting from 0 to 9. Okay, so every number has its equivalent BCD code. So this thing shows here that every decimal number has an equivalent BCD or binary code. So let's just talk about all these codes. So we have a basic BCD code, also known as the basic BCD code. Okay, so it is basically 8421. Now upon this code we do all kinds of binary thing, like we got to know that what is the, for example, if I say that what is the binary of 2, I'll just turn this bit on and I will just turn off these bits, so it will become 0010. So I got to know that the binary of 2 is 0010. Okay, so this is really simple in this way. So we have 8421, also known as binary coded decimal thing. Okay, so using this code, let's just write every instance first, every instances of the binary of all these numbers. Okay, so we're gonna need to have these a 4-bit thing. Okay, so for 0th thing, what we would need to do is to see that which bit will be turned on. So for 0, we know that all of the bits will be 0. Similarly for 1, now here is 1, you can see here 8421, this is the code. Okay, so now here's the 1. You could just have to do is turn this bit on, represented by the 1 state. Okay, and turn every other bit off. Every other bit will be off, so the code will become 0001, or if I say 0001. So for the second term, okay, third term, sorry, it will 0 1, and this one is third term. So for 2, I just have to as I told earlier, that I will have to check this bit on and make all of the other bits to 0. So you know that the binary of 2 is 1 0. Okay, so for making it 4-bit, we're gonna need to just write before it, we're gonna have to read write 2 zeros. So for the 3 we have let me just clear it. So for the 3 we have these 2 bits on. Okay, so 1100. I'm gonna do it really quick now. So 0011. Now for the 4, I'm just have to make this bit on and all this bit off. So 0100. And for 5, we will need to make these bits on. So 1100. Okay, 0101. This is, so for 6 we will have 4 plus 2, which is 6. We're gonna have to make sure that these 2 bits are on. And for 7, we're gonna have to make 7 from here. 4 plus 2, which is 6, and plus 1 7, means all these 3 bits are on. So for 1 1 1 and 0, this is for 7. Okay, for 8 we're gonna have to make sure that only first bit is on. So 1 0 0 0. For the 9th, we have you know that 8 plus 1 will be 9. So make sure that first and last bit will be on, else other bits are 0. Okay, so this is the decimal to binary thing. Okay, using the BCD code. 8421 is generally a basic of BCD. Okay, so So let's just talk about what happens after 9. Okay, so let's see if I have a number 10, 11, 12, and if I say up to 19. Okay, for example, if I take the numbers 19, so you must have to know this thing. Okay, you must have to know that starting from 0 to 9, starting from 0 to 9, this code repeats itself. Okay, like how it repeats itself in a way that let me show you. So if I say that it repeats itself, it means that I again have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now what I need to do is simply add 1 besides each term. So I'm gonna add 1 here, 1 here, 1 here, again. Okay, here we go. So you can clearly see that we have now the 10, 11, 12, 13, 14, but basically it is the repeating code. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so to convert this into its equivalent binary. Okay, now what you need to do, you don't have to look into 8421. Okay, you don't have to do this. Now if for example, if I say 10, you think that if I go here into 8421, I will make the 8th bit on, the first bit on, sorry, the third bit on, and that will make 1010. Okay, so but that is not correct. This is not correct thing. So what you need to do is to break this number into 2 parts. Okay, so to break this number into 2 parts, we have 1 and 0. Okay, so just write the equivalent binaries of 1 and 0. So for 0, the binary will be all zeros, and for 1, the binary will be only single 1 in the end. Okay, so this is the equivalent binary code, BCD code for 10. Now let's just write for 11. The binary of 1 will be this, and again will be this. For 2, the binary will be 0, 0, 1, 0, and for 1 will be same. Now since we know that the first value is always 1 here, let me just write this real quick for you. Okay, so 0, 0, 0, 1, 0, 0, 0, 1 here as well, 0, 0, 1, 0, 0, 1, 0, 0, 1, and 0, 0, 1. Okay, so for the 3, we know that 2 plus 1. Now look at this. Do it bit by bit by using the 8421. Do not do it consecutively, like 1, 0 will become 10 and 8 plus 2 will become 10. We have to make sure these bits are on. No, not like that. Okay, so you have to make it bit by bit. So for 13, we know that the binary of 1 is this, and for 3, the binary will be 2 plus 1, which is 3. So 0, 0, 1, 1. Okay, 14 will be 4. Okay, so 0, 1, 0, 0. For 15, the binary of 5 will be 0, 1, 0, 1. For 16 will be 0, 1, 1, 0, 0, 1, 1, 1, 0, 1, 0, 0, I'm sorry. So for the last one, we will have 1, 0, 0, 1. Okay, this is the thing. So these are equivalent binary codes. Okay, so this was the basic introduction, like how the BCD works in digital systems. Okay, so now what we need to do is actually talk about the BCD addition. Okay, so that's why I told you the overall concept of BCD numbers, like how they work. Okay, and how on the basis of what does the numbers BCD code follows. Okay, so for the addition of BCD, okay, suppose normal addition, we have 25. Okay, and we have here 15 as well. Okay, let's just add those numbers. Okay, now in general mathematics, what will it be? So 25 plus 10, 35 plus 5 will be 40. Okay, so like how we gonna now represent this in BCD, like how the BCD thing will understand this. Okay, so for 25 and 15, make sure that you are the very first step number one. The very first step is to break these numbers into their equivalents. Break these numbers into their equivalents, or if I say break these numbers into one part. Okay, so I have 25 here. Let's just break this. It will be broken down into 2 and 5. Okay, so what is the binary of 2 and what is the binary of 5? You simply know that. So the binary of 2 will be as follows: 8421. Okay, just make sure the bit of the 2 is on and all else bits are off. So we have 0 0 1 0. And for 5, what it will be? It will be this bit on, 4 plus 1 5, and all these bits off. So we have 0 1 0 1 as well here. Okay, so the overall binary will be let me just do this. Okay, step number 2 will be overall binary. So overall binary will be 0 0 1 0 0 1 0 1. Just write it like this. Okay, now for the second number we have 15 here. Okay, we have 15 here, so just write 15. Break this down into 1 and 5. Binary of 1 is, you know, 0001. Binary of 5, you know, 5 4 plus 1. Okay, yes, so the overall binary will be 0 0 0 1 0 1 0 1. Okay, okay, so here I've written those codes. So this is the code that corresponds to 25 and this code corresponds to 15. So 25 plus 15, which should give us 40. Okay, now there is a rule. The rule is if the binary coded of something is greater than 9, then we have to, only in this case, okay, we have to add plus 6 in it. Okay, what I mean by this, you'll get clearly understand this very soon. So we have the code 0 0 1 0 0 1 0 1 and 0 0 0 1 0 1 0 1. Okay, let's just add them first using binary addition. We have 1 plus 1, which is 2. The binary of 2, you know, the binary of 2 is 1 0. So we have 0 here, 1 carry. 1 plus 0 will be 1. 1 plus again 0, 1 here. 1 plus 0 will be 1. And we have 0 plus 1 1 again. 1 plus 0, I'm doing it bit by bit. Okay, for 1 plus 0 is 1 0 0. Let me just see this. 0 plus 1 1 1. Yeah, so now break them apart, okay, into 4 bits. Now for these 4 bits, write the 8421 here, write the 8421 here as well. So let's just see which bits are on. So 2 plus 2 second, third bit and fourth bit are on, so that means the 2 plus 1 is 3. Okay, and for this thing we have 8 plus 2. Okay, so this is the case here now. So we have 8 and the 2, the first and the third bit on, so we have 10 here. Okay, okay, here's the thing. Now if you simply add these terms, 10 plus 3, it gives us 13, which is incorrect. What we need is, our answer should be 40. Okay, so if you encounter any of the problem that includes the binary thing which is greater than 10, okay, greater than 9, then you have to add plus 6 in it simply. This is the basic rule. So let's just add plus 6 only in this thing, only the part that you encounter, the bits, the 4 bits that you encounter. Okay, so 1 0 1 0, let's just add 6 in it. So the binary of 6, okay, you have to add the binary of 6. So for the 6, make sure these two terms are on. So we have 0 1 1 0. Let's just add them. 0 plus 0 will be 0. 1 plus 1 will be 2. 0 here, 1 here. 1 plus 1 will be 2, 0 here, 1 here, 1 plus 1 again will be 2, so 1 0. So this is the code that we get. So the final code is, let me just write here, 0011 for 3, okay, this one here, and the code that is transformed now is Z1 1 0 0 0 0. Okay, so you know that we need 4 bits. Okay, we know we need 4 bits here and 4 bits here as well. So the carry that was generated here, 1 plus 1, after taking 1 plus 1 we get 1 0 here straightly. Okay, so the carry that is generated here, 1, is transferred to the next term. Okay, which means that the carry 1 is deleted from here and is transferred to this term. So I'm gonna add here the carry that is generated here. So 1 plus 1 will be 2, 0 and 1. 1 plus 1 will be 2, 0, 1. 0 plus 1 will be 1 and 0. And all these bits, the 4 bits, were corresponding to 0. Okay, so let's write the 8421 again. So what we get is the 4th bit is on. Okay, the 2nd bit, sorry, if the 4th bit is on, that means the answer will be 4 and 0, which is 40, and this is the correct answer. So this was it for the BCD. And now you can encounter, if you encounter any of the BCD problem, make sure to divide that number. Okay, for example, make sure to divide that number into bits, okay, like this, and write each of the bit binary code, write each of the bit as a binary code. And if the result is greater than 9, don't forget to add the +6 in it. Okay, and if it is not greater than 9, then simply write it as it is. Simply add the terms using the binary addition, and boom, you're all done. So thanks for watching. I hope you like it. Take care.